Alright guys, so tonight we're going to be talking about our Unit 11 Riemann sums. We're going to go through the introduction, which we've already done in class. We're going to take a look into the future, um, and a connection to integral calculus. Okay, we're not really going to do too much of the look into the future in this lecture. I might add that into the end, but we will find the connection to integral calculus, or really actually these two are the same thing. We will connect to the calculus that we're already doing today, all right, that we've already done. So think about, what we've already done and maybe how that could connect into some of what we're doing today. All right, so we're going to start by doing these 4 points. What is a summation? What is a Riemann sum? What is proper notation for a Riemann sum? And the different formulas, RRAM, LRAM, MRAM, and TRAM. Okay, so all right, we've already done this in class, but it's going to help you to see it again. What is a summation? It is the process of adding a set of terms or a sequence of terms, such as first term, second term, third term, all the way to an nth terms. So you could do this for two things, adding two things, or adding an infinite amount of things, or adding 10 things. But you really can't add like 5.5 things. That doesn't work. All right, so all right, let's go with this example. It's kind of simple like we did in class. All right, this summation symbol means basically you're going to add up a bunch of stuff. That's what the E says. And the E is saying, all right, whatever's in here, I'm going to add up a bunch of these things. When this is a sequence, and it starts at 1 and it ends at 4, so that's 1, 2, 3, 4. So I'm going to add 4 things. All right, I'm about to add 4 things. Well, how do I get these 4 things? Okay, so that's what I want to talk about. How do I get these 4 things? Well, these 4 things are the first term, the second term, the third term, and the fourth term. I know there's only 4 terms here in this sequence because it's 1 to 4. All right, but I'm going to figure out what those terms are by substituting 1, 2, 3, and 4. So basically, I'm going to start by plugging in 1. All right, and 4. So that's 4 times 1. All right, plugging in 1 for I, and then 2 for I, and then 3 for I, and then 4 for I. Okay, and so that's basically 4 plus 8 plus 12 plus 16, or you could actually factor out the 4 and do 4 times 1 plus 2 plus 3 plus 4. I just like being fancy, all right? It's really 4 plus 8 plus 12 plus 16. How you write it is up to you. All right, so that's what 12 and 12 is 24, and 16 is 30 and 40. So let's see if that works here. 1, 2, 3, and 4, 7, 3, 10. 4 times 10, that gives us 40 as well. All right, so that's what a summation is. What you have is a certain amount of things, certain amount of terms that you're adding up. Well, to find those terms, first you have to find out, all right, how many are there? And then to find the first one, I plug in 1, second one, third one, fourth one, and fifth one, and sixth one, and however many you need to find. You plug into that I right here. And then the sum tells you you're going to add them all up. All right, so we've already been through that. Let's continue. And got another example here. Alright, so this example I'm about to add 6 things. Alright, right up top here. So I'm about to add 6 things. Alright, this is the formula for the things I'm adding. Alright, and how do I get the things again? Alright, well, I get the things by plugging in 1, 2, 3, 4, 5, and 6. Alright, so let's go ahead and do that. Alright, so that's 1/2. And I'll try to move as quickly as possible. I apologize. To find the first thing, I'm gonna plug in 1. Alright, so that's 1/2, 3 times 1 plus 2. Okay, and 3 times 1, let's just go ahead and find out what it is. 3 times 1 plus 2, that would be 5/2. And let's just go ahead and work it out. So that's the first thing. How do I find the second thing? Well, 1/2, 3 times 2 plus 2. Okay, I know that's kind of hard to see. I'm sorry about the glare there. Let's see if I can fix that. I don't know what's going on with the brightness here. Let's see about the contrast. That worked a little bit, not too much. Alright, so 1/2, 3 times 2 plus 2, plus 1/2, 3 times 3 plus 2. And since I'm going to run out of room, let's just go ahead and ellipse it. And let's finish it out mentally. So the second term is going to be 3 times 2 is 6, plus 2 is 8, divided by 2 is well, let's leave it as 8 over 2. That way they all have the common denominators. 1/2, 3 times 3 is 9, plus 2 is 11, times 1/2 is 11/2. Alright, plus, then 3 times 4 is 12, plus 2 is 14 over 2, so let's leave it 14 over 2. And then 3 times 5 plus 2, just slide it over here. No, I don't know what's wrong with my contrast, guys. 3 times 5 plus 2 is 15, plus 2 is 17 over 2. 17 over 2. And now we see a pattern emerging here. Alright, we're basically adding 3 every time, so I know the next one is 20 over 2. Okay, now all these are over 2. I wrote down here manipulations, fractions, yay, because you can do some fraction manipulation here. I can factor out a 1/2 and just do 5 plus 8 plus 11 plus 14 plus 17 plus 20. And so 5 and 8, 13 and 11, 24, 38. I better double check that. And so that's 12 and 11 is 23. Yep. 12 and 11, or sorry, nope, 13 and 11 is 24, and 14 is 38, and 17 is 48, 55, plus 20 is 75, so 75 over 2 after you multiply it. Alright, so there you go with the multiplication there. Now there's a different way you could have done this now. There's a different way you could have done this. We could have said, alright, well there's the half. I could have actually factored that half out, because notice they all have a half. Notice they all have a half. Alright, so you could have factored that half out to begin with and said, alright, I'm going to do the same thing, but I'm going to factor out the half first. So that's going to be, alright, 3 times 1 plus 2 plus 3 times 2 plus 2 plus 3 times 3 plus 2 plus 3 times 4 plus 2. Let's see if I'm running out of room. Yep, I am. Dot, dot, dot. So we got an ellipse there. Alright, now the next thing is, well, what do I have every time I got a plus 2? Right? So what is adding 2 6 times? Well, adding 2 6 times is the same as adding 6 times 2. So I can simply just say, all right, it's 1/2. I'm going to get rid of that plus 2, and I'm going to say it's 6 times 2. All right, so there it is. All those plus 2's are gone. Okay, the plus 2's are gone. I'm going to try to see if I can change the lighting here, guys, because this is kind of bothering me. Alright, that's much better. We'll just stick with that, even though there's going to be some shadows. So here we got all the 2's are gone. We got 6 times 2. Alright, now we have the 3 times 1 and the 3 times 2 and the 3 times 3 and the 3 times 4. Well, that's all multiplying by 3. So watch, factor out of 3. 3 times 1 plus 2 plus 3 plus 4 plus 5 plus 6. Notice I don't have to do any ellipses here anymore. No ellipses, because I've actually broken down the entire thing and done some algebraic manipulations to make my problem much easier, and it should end up being the same thing. If not, I made a big old goofy mistake. 12 plus 3 times 1 plus 2 plus 3, 6 and 4 is 10, and 5 is 15, and 6 is 21. 3 times 21. Oh boy, I hope this is right. 1/2, 12, 3 times 21. 3 times 21 is 63. 63 and 12 makes 75. So yep, 75 over 2. You get the same thing. Now you don't ever have to do all this manipulation, but you know, it's fun to know that you don't have to stretch this all the way out. This is boring to me, and I'm sure it is to you. I would much rather see this than see this any day. Alright, so that's summation. You know, it tells you how many things you're going to add. It tells you a formula for what you're adding, and that's it. So, very good. Let's move on. Now, we're going to go into the last few topics. What is a Riemann sum? We already talked about this. The short part of it is we're adding up rectangles and trapezoids to approximate area. Well, how would we adding up the area, sorry, I should have been more specific, the area of rectangles and trapezoids in trapezoids to approximate the area. Okay, and how would I add up the area of rectangles? Well, that's a silly question. We add up all the areas we get from the base times height. Or in the trapezoid case, we add up all the areas we get from 1/2 base 1 plus base 2 times height, the trapezoids. Or even better, okay, since we're adding up stuff, just think about that. All we're doing is adding up stuff, so why not use the summation symbol? Here's the summation symbol. We're going to add up, and I guess we're going to add up some base times heights. We're going to add up some areas, some rectangles. This would be the rectangle area formula and the trapezoid area formula. So we add up the rectangles and we add up the trapezoids. If we need to do trapezoids or if we need to do rectangles. But even better, we can tell us how many rectangles are we adding up and how many trapezoids are we adding up. And actually you can use this formula on the AP exam all day long on the AP exam. These are AP exam formulas, and all they mean is you're going to add up some rectangles or some trapezoids. And so if you see 4 rectangles, well, you'll write this formula down, and then you'll do your base times height for each rectangle, and then ba-boom, you got it. And if you see 5 trapezoids, you'll use the formula for each trapezoid. All right, and you got it. All right, so just know that these may look simple, but they are going to be used on the AP exam. Every single AP test uses these 2 formulas. Alright, so let me write that down. On AP test. Used. Okay. Alright, so, alright, that's good enough of that. So here we go. Moving on. Oh, I don't need to take it off. I need to put it on. Alright, here we go. Alright, so how do I use these formulas? Let's do examples. Well, I can't show you yet. All right. First, you need to have written down, and I'm sure you've already got these written down. I'm sure you have them written down. They're the 4 formulas for 4 types of Riemann sums. But maybe y'all didn't write this one down. The TRAM, the trapezoidal approximation method. That's one of the 4 that we have to know. Okay. So I'm talking right now, so in case you weren't here in class on Monday, you could write these down. That's the only reason I'm talking. All right, so let's move on. Now let's do some examples. First, we're gonna break down the RAM formula. Let me go ahead and note each time that there is an easy way of doing this, and then there's a hard way. You have to be able to do both. So on each of these problems, you'll notice I'll do it I'll do it the easy way first, and then I'll go into the difficult way. Okay? So the easy way is just basically using the graph and the givens to figure out the areas and just add them up. So let's go ahead and start it with the easy way. Alright, we're on the interval 1, 4 on x. We're going to use 3 subintervals. So we're sticking to this interval right here, 1 to 4, and we've got 3 subintervals. That means three rectangles, if you will. Okay, which means you're going to have a RAM. So that means we're going to use a right endpoint rectangular approximation method. Alright, so each of these 3 rectangles, they're going to start out the same, but when, like say this number 1, this is going to hit and stop at the right endpoint. Number 2, that's going to hit and stop at the right endpoint. Number 3, that's going to hit and stop at the right endpoint. You can't go any further. Now the next step in all this is to find the points, the important points. And I guess we could find every point here. We could find this point, I guess, if we wanted to. How would we find this point if we wanted this point? We'll plug in 1 into the function, negative 2x plus 12, so that would be 1, and then when I plug it in I get 10, and then this one 2, and then when I plug it in I get 8, and then this one 3, and then when I plug it in I get 6, and this one 4, when I plug it in I get 4. And that tells me a lot because now each of these are my bases, and I'll get into more of this later. Each of these are my bases. Alright? And not this one. This one don't matter, but each of these are my heights. So here I got the summation formula. Alright? I'm going to add up 4 things. Okay? And I'm adding up the base times the height, so let's go ahead and add them up. What's the base times the height? Well, the first area is just base is 1 times height is 8. So that's just 1 times 8, and you have to write this on the AP exam. If you don't literally write out the 1 times the 8, you lose credit. Let me write this down. Sorry. You lose credit if not written. Okay? You lose credit if you don't write the base and the height. Okay, so all right, so 1 times 8, and then the second base is 1, and the second height is 6, so 1 times 6, and the third base is 1, and the third height is 4, so 1 times 4. All right, so there you go, and then I'll just rewrite it all again, just to be tasteful. 8 plus 6 plus 4 equals whatever that equals. 8 to 6, 4, 18. 18 units squared. Make sure we put units squared because it's area. Okay, now this was the easy way because it was kind of common sense based on the bases and the heights. Now let's go into the hard way. Alright, the harder way is to, when we did this in class for my third period, the hard way is to ascribe values for each the base and the height. We want to algebraically identify the base and algebraically identify the height. So the easiest one to start with is the base. What could I call this that would be algebraically sound? What could I call it? Well, actually, I'm going to give it, it's how the x values are broken up. And I'm going to say that it's called the change in x. Well, how did I get the change in x? I got the change in x because I knew I had an interval that was 1 to 4, which is a distance of 3, divided by 3, and 3 divided by 3 is 1. Well, I need a formula for that, and it's b minus a divided by n. What does that mean? Alright, b minus a divided by n. Let me get some room here. Oh, running out of room. Running out of real estate. Alright, so b minus a over n is the formula for the change of x. What's b? B is 4. A is 1. And so delta x is 4 minus 1. And n is the number of rectangles. Alright, n rectangles. And it kind of matches up with over here because we had 1 to 4. We're adding up. Oh Lord, did I really put 1 to 4? I'm so sorry. That's 1 to 3. We're adding up 3 things. We're adding up 3 things. Lord help me. Alright, so it matches up with the n that should have been here, should have been 3. 4 minus 1 over 3. So delta x is equal to 4 minus 1. And remember, I'm sorry I messed that up. We were adding 3 rectangles. That's why there's a 3. 1, 2, 3 rectangles. 1, 2, 3 areas of rectangles. So 4 minus 1 over 3 is 3 over 3, which is 1. So this is the formula for delta x. Alright, so if delta x is here, alright, what could I label each of these x's? Alright, so what I'm going to do is I'm actually going to label this x as x sub 0, x sub 1, x sub 2, and x sub 3. I know that's hard to see. Well, I'll tell you what, this isn't exactly what the best way of writing that in. And you don't necessarily have to label that x sub 0, x sub 1, x sub 2, x sub 3. Alright, so let's get rid of that there. That's not necessary. Okay, I can show you that here in a second using the actual formula. Alright, so the actual formula here, what we've got the base, now we want to get a formula for the height. Well, the height is the y. Notice all the heights are the y's, okay? So the heights are the y's. So basically we can make a statement saying h is equal to f of x, right? So that's what we need to find. But which f of x? Well, it's 8, 6, and 4. Well, how then do we know that x is 2, 3, and 4? See, what we need here is a formula for x. We can't find f of x unless we know what x is. So this is where we take the fact that this is a RAM, and it comes into play here. Alright? The fact this is RAM, we're going to use the x of IR formula. And you'll see how this formula works. It's fairly simple. X of IR, alright, it's A plus delta x times I. Alright? Now, I'm sorry I can probably confuse you with the x of 1, x of 0, x of 1. Don't worry about all that. You'll see how this x of IR works here in a second. So x of IR, alright, is A. What's A? Well, A is 1. Plus delta x. What's delta x? Delta x is 1. Times I. What's I? Don't worry about it. We're not there yet. Alright? X of IR. 1 plus I. Now, does this make sense? This is a formula for a sequence, so we start by plugging in 1. Alright? Well, let's see. Does that make sense? What happens when you plug in 1? You should get the first x. Plug in 1, do you get the first x? 1 plus 1 is 2. Yes, I get the first x. It matches up beautifully with the first y. Well, what about the second x? So I plug in 2. 1 plus 2 is, 1 plus 2 is 3. That's the second x because it matches up with the second y. I didn't care about this 10, right? Because it's not part of my problem. Alright, so what's the third x? 1 plus 3 is 4. Well, does that match up with the third x? Yes. And if I plug it in, it gets the third y. But here's the problem. I've got to take this x of IR formula and turn it into, and put it into the f of x formula. And this x of IR formula gives me the proper x's, but unless I substitute it into the f of x formula, it's not going to give me the proper y's. Okay, so we've got to substitute. So now, so here's step 1, if you will, or step A, or I'll Roman numeral. Step 1, right here, find your delta x. Step 2, right here, find your x of IR. Step 3, oh, sorry, I had to start over. I was doing Roman numerals. Alright. Step 2, right here, find your x of IR. Step 3, I'm going to make it over here because I'm running out of room. I told you this was the hard way. Now I have to find f of x of IR. Okay? So f of x of IR, and I'll tell you what, let me do it on another sheet of paper. I'm running out of room. Good thing I have this handy. Alright, so step 3, we're doing f of x of IR. Alright, and let me go ahead and zoom in here. So we found x of IR. We want to find f of x of IR, but first we need to remember that f of x was equal to negative 2x plus 12. Alright, so f of x of IR, we're going to substitute I plus 1, alright, into whatever the x was. So really it's going to go right there, okay, into the negative 2x plus 12. So f of x of IR will equal negative 2, 1 plus I, replacing the x, plus 12. Alright, so this is not very difficult. Now we distribute f of x of IR, distribute negative 2 minus 2I plus 12, and then f of x of IR equals negative 2I plus 10. And now we have a formula for our height. So let's back up. We said the height was equal to the y value, the f of x. But we didn't have a formula for each of these heights, the 8, the 6, and the 4. So what we said was, okay, I'll make sure the x's are right by using the x of IR formula. Once I get my x's right, I'll plug it into the f of x formula, and I'll have the perfect f of x formula, the f of x of IR formula, to plug into my summation. So let's go back to the summation, okay? We had a rudimentary, easy summation going on till I messed it all up and gave you this complicated stuff. We're adding up three things. Our base is delta x now. Our height is f of x of IR. Alright, do we remember what delta x was? Oh yes, we should. Alright, so let's be tasteful. Delta x was 1. F of x of IR was, oh, we already found it. So now we have the perfect formula. Negative 2I plus 10. Alright, so that equals, let's see if it works. I hope it does. What was our answer before? Our answer was 18 units squared. See right there? Let's see if it matches. So let's see if y'all remember how to work these out. This one really doesn't matter. I don't have to multiply everything by 1. I can just say that I distributed that. So let's just go ahead and say it's not there. Alright. But if you're doing a base times height problem on the AP exam, you probably want to keep your 1. Let's plug in 1, 2, and 3. So negative 2 times 1 plus 10 plus negative, am I running out of real estate already? Negative 2 times 2 plus 10 plus negative 2 times 3 plus 10. Alright, let's hope we get 18, otherwise something's wrong. Negative 2 plus times 1 plus 10 is 8. Negative 2 times 2 is negative 4 plus 10 is 6. Negative 2 times 3 plus 10 is negative 6 plus 10, which is 4. 6 and 4 is 10, and 8 is 18. 18 units squared. Okay. So, I told you it was the hard way. Alright, so let's back up. So here we have a little glimpse of all the steps that you need to be able to do. Alright. Step 1, find your change of x. Step 2, find the x of IR. Step 3, find the f of x of IR. And then step 4, finally, work out your summation. Okay? Alright, so I know that really took long. On the next examples, I'm going to be booking it because I'm taking a long time and I'm sure you're fast forwarding already. Alright, so next example. Alright, so what we did was the RRAM formula. Okay? We found the RRAM formula, and it was RRAM because it was the x of IR that made it the correct RRAM formula. Now guess what we're going to use? Well, x of IL, because it's LRAM. Alright, so let's do it the easy way first. On 1, 4 on x, so we're going 1 to 4. Alright, so we got 3 rectangles, but now it's a LRAM. So our rectangles will come up here, here. And now we're going way too high. Well, this is called an upper sum. This is called an upper sum. Okay? It's an upper sum because I know that this area is going to be more than the actual area under the curve. If you shade in the actual area under the curve, it's more than the actual area. Okay? Alright, so let's go ahead and do it the easy way. Remember, easy way, I'm adding 3 things. I know they're base times height. I simply find the points. This one, I'll find it, but I know it doesn't matter. Alright, it's 1, 10, and then 2, 8, and then 3, 6, and then 4, 4, and I got that by just plugging it in here. Okay? And I know that this base times height is going to end up being the bases, all the bases are 1. Okay? All the bases are 1, so it's 1 times 10 plus 1 times 8 plus 1 times 6. Oh, bad bracket. And that's going to equal 10 plus 8 plus 6, which is 24 units squared, don't forget. Alright? So that was the easy way. Now let's do it the hard way. Well, I hope you remember what the first step was. The first step, well actually the first step is to remember what you're dealing with. Let's write the formula from I equals 1 to 3. We know that the base is delta x. You remember that, you'll be good. And you know the height is now, it's f of x of IL. Alright? The height is f of x of IL. Alright? So we got to find this. Well, that's easy. Alright, we know that because there's a formula for that. Hopefully I've still got lead. There we go. I equals 1 to 3. And if I want to be thorough, so I'm going to actually work the formula out. 4 minus 1. No, sorry, b minus a over n. So 4 minus 1 over 3. So delta x is equal to 3 over 3. Delta x is equal to 1. You don't really have to work that out, y'all. But we do have to find that. That's the hard part right there. So this is step 1. Actually, that's step 1, but we'll call this step 1. Step 2, we'll say it's find, we got to find this, but first we got to find x of IL. There's a formula for x of IL. It's a plus delta x times I minus 1. Okay? Now the reason it's minus 1 is because instead of the x's being 2, 3, 4 like last problem, now they're 1, 2, 3. It's just minus 1. Alright? So x of IL, let's hope this comes out easy. I think it'll come out easy. 1 plus, the a is the 1, it's the beginning. Alright, b is the end. And then delta x is 1, and then I minus 1. Alright, so x of IL is equal to 1 plus I minus 1. Oh my goodness. X of IL is equal to I. Okay? Well, that's a good thing, because then f of x of IL will be very simple. Okay? Let's go ahead and find the f of x of IL. Let's see. F of x of IL is equal to, remember we're just going to take this and substitute it in the f of x, which was negative 2x plus 12. So now we're taking the I and plugging it in there, the x of IL, and plugging it in there. So now we're just replacing an x with an I. It's like we almost didn't do anything. Well, who cares? Cha-ching, you got what you need. Alright? You got what you need. So there's f of x of IL. So smack it in there. Negative 2i plus 12. Okay? Now, so I hope you see all these steps. This is actually step 4. It's fairly simple. If you know what delta x is and you know what this is, then you know what that is. So you plug it in, and now you just have to do the work, and it's just time consuming, huh? I know. All right, so let's see how we finish this. All right. So we're gonna plug in 1, 2, and 3. All right. So plugging in 1, I'm just gonna forget about that 1 right there. Plug in 1. We got negative 2 times 1 plus 12. That's 10. And then negative 2 times 2 plus 12 is 8. And then negative 2 times 3 plus 12 is 6. And 10 plus 8 plus 6, well, that gives you the same thing, 24 units squared. Okay? Let me back out of that. Alright, there it is. In a very small compact area. Alright, so hopefully this helps on x of IR and x of IL, giving you the formulas. Obviously you need them. But basically this is it, guys. We'll be doing these 4 steps for every single one. Alright, let's move on. I know I'm taking too much time already out of your Thursday, or whatever day it might be, or whatever year it might be. Alright, let's break down the MRAM formula. Okay? We got the same formula that we did last time, except for we're on 1 to 6 now. Okay? And we got 3 subintervals. Well, this is different. Alright? So when we draw, we got 1 to 6. Oh, Lord. I didn't mean to make it 1 to 6. I guess I need to change that. Let's make it 0 to 6. 0 to 6. Alright, there you go. 0 to 6. Well, obviously there's a reason why I made it 0 to 6, and now you can divide it equally, right? So, and now if we got 3 subintervals, well, let's find our delta x. Let's find our base. What's delta x going to automatically equal here, y'all? Let's see, delta x equals b minus a over n. Alright, b is 6, a is 0, so that's 6 over 3 subintervals, so that's 3 rectangles, 6 over 3, so delta x is equal to 2. This helps me because I know my rectangles are 2 units wide. Rectangles 2 units wide. Alright, so each of these are 2 units wide, and it's an MRAM, so that's then for midpoint. So now, when I take this and I go, I'm going to go so that the y value in question here is going to be at the midpoint. So here, boom, trying to get this right as best as possible. So let's go ahead and, we know this is 2, but that's good. What are these points? So that's 1 comma what? We've already done this. 1 comma 10, and then 3 comma 6, and then 5 comma whatever that is, 5 comma 2. Didn't do that one. Alright. So we know we start off with this, where we've got how many rectangles? 3. So I equals 1 to 3, base times height. So we're going to do base is 2 times height is 10. So 2 times 10 plus 2 times 6 plus 2 times 2. So 20 plus 12 plus 4 rewriting tastefully everything. I equals 1 to 3 base times height equals 32 plus 4, which is something. 32 plus 4. Yeah, I can't count. 36 units squared. Alright? Alright, so there you go. That's the easy way. Let's find out the hard way. Alright, so MRAM. MRAM, you're going to have to do a couple things. Alright, you're going to do the same steps. We've already done step 1. We found delta x. Okay? We've already done step 1. We're going to have to do step 2, which is find x of IM. You guessed it. Alright, that's going to be A. Notice we always have A plus delta x times I minus 1/2. You could use 0.5 if you want to. You can use 0.5 if you want to, but it needs to be I minus 1/2. So x of IM, we're going to fill in. A is 0 plus delta x is 2 times I minus 1/2. So x of IM equals 2I minus 1. Now we have to do the dreaded f of x of IM. You're going to learn not to like f of x of I, whatever. Alright, so that equals, now we've done this before, we're just taking 2I minus 1 and plugging in the original f of x. The original f of x was negative 2x plus 12. I know I don't need to write that again, hopefully y'all remember. So we're going to plug that in for x, and we have to use parentheses, negative 2 parentheses, 2I minus 1 plus 12 f of x of IM equals negative 4I plus 2 plus 12 f of x of IM equals negative 4I plus 14. There we go. Let's test this. Plug in 1, what do we get? 10. Plug in 2, what do we get? 6. It works. It works. It works. So let's just do our step 4 now. Okay. Step 4. I'm running out of room, running out of lead. I didn't plan on taking breaks. Summation from I equals 1 to 3. We're adding up 3 things of delta x. Okay. Delta x, which is 2 times f of x of IM, which is negative 4I plus 14. Here's an interesting point. We can factor out the 2, or we could just distribute it before we start adding. I'm going to factor out the 2. I'm going to factor it out. That way I don't have to write big numbers. So I'm going to write it as such. Let's see. Don't have much room, so I've got 2 parentheses. Negative 4 times 1 plus 14 plus negative 4 times 2 plus 14 plus negative 4 times 3 plus 14. Now, you don't have to write all that out like I do, but basically I'm plugging in 1, I know I'm getting 10, I know I'm getting 6, and then I know I'm getting 2, so it basically ends up being 2 times 10 plus 6 plus 2. And 10 plus 6 plus 2 is 18. 2 times 18 equals 36 units squared. Okay? Alright, so there you go. Alright. Alright, okie dokie. Hopefully this isn't taking too long, guys. I'm going as fast as I can without thinking I might leave anybody behind. Alright, we got a few more to go. Alright, and then I got some extra examples. I think I'll just post them. I'll post them in another video. Alright, and go ahead and start working on your notes for your PowerPoint. Alright, so breaking down the TRAM formula. Alright, so let's do the TRAM formula. We got 4 to 10, and I'm going to start moving faster, guys, because if you go slow, it takes forever. So from 4 to 10, alright, and then 3 subintervals. So, and they're trapezoids, so they're going to look like this. They're going to look like that, right there. The bottom will always be flat. So 4 to 10. Let's find our delta x. Delta x is 10 minus 4, 3 subintervals. So 6 over 3 is 2. So I know that each of these trapezoids are going to be 2 units wide. And so I'm going to go here, here. Wow, oh my goodness. That just looks like a rectangle. Okay, I'm sorry, I apologize. This example is kind of bogus. But then here to here, that looks like a good trapezoid. Then 9 to 10 is not even a trapezoid, it's more like a triangle. So these are all trapezoids, sort of. Okay, this one's more of a rectangle, but that's just the way it ended up being. Let's find our important points so we can do it the easy way. 4 comma what? What do I get when I plug in a 4 here? Negative 16 and 40, 24. And then 6 comma, it's actually 24 as well. And then 8 comma 16, I believe so. Let me double check that. 8 squared negative 64 plus 80. Yep, that's 16. And then 10 comma 0. Okay, so let's break down the easy way. Easy. Alright, so you got your summation. I equals 1, 3. Got your 1/2 base 1 plus base 2 is height. Now look at here. Your height is not actually the height anymore, because you see, like this example, your base 1 and your base 2 are actually the heights. And your height is actually each of these distances right here is a height. So it's like you got the trapezoid laid on its side, so now the height is the base. So the height is going to always be 2. So, and here's where if you're smart about this, you know the height is always 2. Well, 2.5 kind of cancel, right? So I could use that to my advantage there, but I'm going to write it all the way out. Alright, so 1/2, let's look at my first one. Base 1, 24, 24. So 24 plus 24 times 2. And I'm already seeing that this is causing me way too much writing. I probably should have, let me zoom in real quick. Okay, 24 plus 24. Alright, let's look at the second one. Alright, 24 and 16, so I got one, let me write it over here. 1/2 24 plus 16 times 2 plus 1/2. And this last one is actually a triangle, so it's 1/2 base 16 but there's no other base, there's no base 2, so just was basically 1/2 base times height, which is what and the height is actually 2, or 1/2 height times base, whatever. So these actually cancel, all these cancel when I add them up, so I get this equals 48 plus 40 plus 32. What does that give us? 48, 40, 88, 32, 90, and 120, 120 units squared. Okay, there we go. So that's not too bad. Now you're thinking, oh my gosh, what have we gotten into now? Alright, well, alright, so the TRAM formula in the doing it the hard way is, let me go ahead and get some extra paper. It's a little bit more difficult than the other two, but it's fundamentally the same. So let's get started. So what we have here is, let me just go ahead and zoom in. Just a tad. Alright, that'll work. So we know we're adding 3 things. Alright, and we know our formula is 1/2 base 1 plus base 2 times the height. Okay, so let's figure out what base 1 and base 2 are. But we see over here that base 1 and base 2 are the y's. One is the left endpoint, or sorry, one is the left y, the left rectangular endpoint, and one is the right rectangular endpoint. But instead of picking one or the other, now I'm picking both and adding them together. So that leads us to believe that this is actually one half always stays the same. Base 1 is my left height. It's actually f of x of il. And base 2 is my right height, f of x of ir. And my height is this thing on the bottom. Well, what was that called earlier? That was called the change in x. Alright, so there you go. That's it. So we're going to have to do all that. We're going to have to find f of x of il, f of x of ir, and delta x. So this is going to take a lot of foiling and working, okay? Alright, so here we go. Let's go ahead and get started. Alright, so step 1, find delta x. And look, we've already done step 1 right here. Alright, so we know delta x equals 2. Let me scroll down a little bit. Alright, and we want to find, let's start with f of x of il. So we need to find x of il, which is a plus delta x I minus 1. And then our a is 4. 4 plus delta x is 2, I minus 1. And then I have 4 plus 2i minus 2, and then 2 plus 2i. Okay? Alright, and I might as well go ahead and find my x of ir. Okay, so let's go ahead and do that. My x of ir is equal to a plus delta x I. X of ir is equal to 4 plus 2i. And that's it. Okay. Now, so there's step 2. Done both times. Step 3 is going to be a doozy. Okay. Because you've got to, I'm going to need some more paper for this one. Alright, step 3 I'm going to have to find f of x of IL and f of x of IR. Okay, so f of x of IL equals, well, first I need to know what f of x is. F of x is negative x squared plus 10x. Here's where it gets tricky because we got a squared. Well, that's fine. Don't bother me. I'm going to plug this in everywhere I see an x. Doesn't matter. So that's negative 2 plus 2i plus squared plus 10 parentheses 2 plus 2i. Sorry for rambling there. Alright, and then I have to FOIL it. F of x of IL, and foiling's not a big deal. Bring down my negative. 2 plus, wait, sorry, I'm foiling. I forgot. First is 4, and outer would be, let's see, let me break it up. I'm going to show y'all, show it broken up here. Right here, negative 2i plus 2 times negative 2i plus 2. Outer would be negative 4i. My inner would be negative 4i. Last would be, well, I switched it up, but that's, oh, doggone it. How did I distribute that negative? Alright, so the negative is still there, so that's 2 plus 2i times 2 plus 2i. Okay, so we have outer's 4i, inner's 4i, and the last is plus 4i squared. Plus 10, 2 plus 2i. So f of x of IL, right, equals, combine those, I get 4 negative 4 plus 8i plus 4i squared, and then plus, well, I'll distribute that 20 plus 20i, and then f of x of IL, negative 4 minus 8i minus 4i squared plus 20 plus 20i, f of x of IL equals, 20 and negative 4 make 16, negative 8 and 20i make plus 12i minus 4i squared, and there I go. There is f of x of IL. Okay. And I still got to find f of x of IR. Alright, so here we go. X of IR. Alright, so there was f of x of IL, for those of you who didn't see it. X of IR is equal to 4 plus 2i. And f of x of IR, let's recall what f of x was. F of x was negative x squared plus 10x. Alright, so that's negative 4 plus 2i plus 10, 4 plus 2i. F of x of IR is going to equal, got to FOIL that out, it's squared, sorry about that. FOIL that out right there. So negative 16 plus 8i plus 8i plus 4i squared plus 40 plus 20i. And distribute the negative. After you combine like terms, you get negative 16 minus 16i minus 4i squared plus 40 plus 20i. Combine like terms, negative 16 and 40 make 24 plus 4i minus 4i squared. Okie dokie. So 24 plus 4i minus 4i squared. Alright, whoa, I ran out of real estate really quick there. Alright, so there you go. Alright, f of x of I, IL and IR right there. And now I need to combine those into the summation formula. Well, what was the formula that I had to begin with? Okay, let's scroll back up and take a look. Alright, that's 1/2 of f of x of IL plus f of x of IR plus delta x. Okay, alright, so we've got to use that. Okay, so summation I equals 1 to 3 1/2 f of x of I L plus f of x of I R times delta x. Well, we know what delta x is, so that's summation I equals 1 to 3 1/2 f of x of IL is 16 plus 12i plus minus 4i squared. Let me go ahead and zoom in here because I'm done with that other part. And then plus f of x of IR plus 24 plus 4i minus 4i squared. And delta x was 2. Now I combine like terms, 16 and 24 make 40. So 1/2 40 plus 12i, 12i, no sorry, 12i and 4i make 12i and 4i make 16i, and negative 4i squared make negative 8i squared. Times 2. Well, here I'm definitely going to take the liberty of crossing out the 2 and the 1/2 because it's just, well, we got a lot going on here. Alright, so I'm going to go ahead and do that. I'm just going to do that. Alright, and in fact, I can take this a step further. I'm just going to write my E. I'm getting kind of tired. I'm going to go a step further here, and I'm going to factor out an 8. I'm going to factor out an 8, and I'm going to say this is now 5 plus 2i minus I squared. Makes it a lot easier. So now the summation is going to equal, finally, 8. And then I know I've got this 5, and I'm going to add it how many times? 3? Yep. So I'm just going to do 5 times 3. And then the 2i, I know it's going to be 2 times 1 plus 2 plus 3. 2 times 1 plus 2 times 2 plus 2 times 3. So, well, I can just write that out. 2 times 1 plus 2 times 2 plus 2 times 3. Alright, let me back this up. So now I've taken care of the 5, I've taken care of the 2i, and now I've got to plug in 1, 2, and 3 into that. So that's going to be a negative 1 squared plus a negative 2 squared plus an, oh, I'm still running out of space. Alright. Plus a negative 3 squared. And there I have it, 8. And then that's 15 plus 2 plus 4 plus 6 minus 1 minus 4 minus 9. So that's 15 plus 2 is 17 and 4 is, sorry, 15 and 2 is 17 and 4 is 21 and 6 is 20. 7 minus 1, 26, minus 4, 22, minus 9, 11, and then 8 times 11 is not the same thing I came up with to begin with. Holy smokes, that can't be right. Alright, 2, 4, 6, 15, 2, 17, 4 is 21, 6 is 27, minus 1, 26, minus 4, 22, minus 9, 13. Minus 1, 26, minus 4, 22, minus 9, 13. And then 8 times 13 is almost 120 units squared. It's close. It's 124. No, it's 104. Sorry, 104. I wonder how I messed that up. 104 units squared. Okay. Well, let's see. I don't know exactly. See, 48 here. Let's look up here. I may have made a mistake. So 48 plus 40 plus 32, so 30, 16 times 2. Wait, wasn't that supposed to cancel out? Yeah, it's supposed to be 16. Oh, darn it. 16. So I subtract 16 from that. It's 104. Alright. So wow, I've taken up a page of work for one problem. So I think this is where I'm going to take a break, and I'll get back to y'all later with the other examples.